formulas you're going to need. I wanted to demonstrate this question because this question is about a circle, and it's checking if a point is on a circle. Keep in mind that the definition of a circle is all the points equidistant from that center point. And so when we're looking at the circle, we can use the radius of the circle. This radius we can see because we have the point 0, 0 and the point 4, 0. We can see that the radius length is 4. That means that any point on the circle is 4 away from the center. They wanted us to check the point 2 square root of 12. So if we go to the x value of 2, and I'm just going to act like it's on the circle because that's what we're checking. And I'm going to be drawing in this radius between the point we're hoping is there and the origin. And I'm going to create a right triangle. You could use distance formula, or you could make a right triangle out of it. And using the point here, since it's a distance from 0, 0, we know that the x value of 2 is this length of the triangle. And then the y value is the height. And so I'm going to do distance formula to check, is the radius 4 like it should be? And if it is, then it is on the circle. So I'm going to do Pythagorean theorem, checking my right triangle there with my 2, my root 12, and my 4, and I'm going to see if this works. So my a squared plus my b squared should equal my c squared. This is 4. The square root, when you square a square root, the square root and the square cancel, and you just get what is inside. 4 squared is 16. These do add to 16. 16 does equal 16. So this point is on the circle. So the answer to that, yes, it's on the circle. And we checked it with the distance formula, or Pythagorean theorem in this case. I'm going to skip ahead because I know time-wise we don't have time for every slide I have here. Here I have two forms of an equation. I have slope-intercept form, which is this one here. And I have point-slope form. There is another format called standard form, where you have ax plus by equals c. If you're in standard format, the a, the b, and the c have to all be whole numbers, and your a must be a positive value. These are the three forms of equations that you could have. We are most typically going to be starting with point slope, and then you're going to take the point slope, and you can use it to create the slope intercept, and if you really want standard, you would go from slope intercept to standard form. So I'm going to demonstrate writing an equation in all three formats with this question. They've given us 2 points, and they want us to write an equation in point slope and in slope intercept form. They've given us 2 points on the line. This is going to be my x1, y1, and my x2, y2. If you need to write an equation between 2 points, you need to start with the slope. So I'm going to calculate the slope using the slope formula. Remember, the slope formula is my y2, which will be 6 minus my y1, negative 3, over my x2, negative 1, minus my x1, 2. Minus minus is adding, it's going to be 9. That's going to be negative 3. It's going to reduce to negative 3. So the slope that I need for the equation is negative 3. The next thing I need, since I don't have a y-intercept, if they gave me a y-intercept, I could go straight to this slope-intercept form. But I don't have a y-intercept, so I can't do that. What I'm going to do next, I have a slope, I have some points. I'm going to go to point-slope form. You get to choose the point that you would like to use. You look at the 2 points they gave you. If one looks better than the other, you would use it. I'm going to use this first one because either way here, nothing is better than the other. Let's see. I'm going to use the slope is negative 3. The point I'm using with my x1 is 2. My y1 is negative 3. And I'm going to plug into the formula. The things that you're going to fill in are the x1 and the y1 and the m. The other x and y are going to stay there because to have an equation, we need an x and a y. So we're going to say y minus the y1, which is a negative 3, equals the m, which is negative 3, and then x minus the x1, which is 2. So just using our x1 and our y1 from here and our slope from there. I'm going to simplify to y plus 3, negative 3, x minus 2. This is the point-slope form of the equation. And we use this to create the other forms if we need them. So if I am wanting to do the slope-intercept form, I'm going to take this format and I'm going to go over here. I'm just going to copy it. And I'm going to solve for y, and that's how I'm going to get that slope-intercept form. So I'm going to distribute the slope, the slope there, negative 3x plus 6. And then I'm going to subtract 3 to get y alone. Y equals negative 3x plus 3. And that is the slope-intercept form of the line. If I then were to want standard form, I would take this, and I'm going to copy it. And what I'm going to do is get it into standard form. Standard form, just rearranging it and so that you have all whole numbers, so that you start with your x, and then your y, and then your equals, and then your constant. So I'm going to add the 3x because it's negative, so we're going to add it to move it. And then we're going to pause, and we're going to see, do I have whole numbers? Are there any fractions? There's no fractions, so we're good. Is my x value positive? It is, so we are good. This is standard form. So those are the 3 forms of equations that you could have. And sometimes they have questions where it's like check all that apply, and so they might have the different formats, and so you need to be able to convert from one to the other so that you can check your answers. All right.